Alright, Titans, welcome to the first installment of your flipped classroom here. We are looking over section 12.1, the fundamental counting principle and permutations. With this first section, we're just going to talk about the fundamental counting principle because it is a lot of fun. Fundamental counting principle is a way to figure out the total number of ways different events can occur. So if I go out to dinner and I look at that menu, it's got all these different entrees, all these different appetizers, all these different drinks. It's basically going to tell me how many different ways I could possibly order. So, looking here, if you've got two events, and one event can occur M ways, and another event can occur N ways, basically just M and N are numbers there, then the number of ways that both can occur is M times N. So we're just going to end up multiplying the number of ways. So looking here, I'm going to make a sandwich. And I've got 4 types of meats. And I've got 3 types of breads. Well, what I want to do is I want to know how many different types of sandwiches I can make. Without this fundamental accounting principle, we can use this long way. And I'm just going to show it here. You don't necessarily have to know this. It's just another way. Which says, basically, it's a tree diagram. And we go off, draw our branches of our tree here, and we've got our 4 meats, our ham, our turkey, our roast beef, and our pastrami. From each of these, you draw another branch. And from each branch is going to be your 3 types of bread: white, wheat, and rye. And we've branched off our meats, we've branched off our breads. So what I have there is I have a choice of ham on white, ham on wheat, ham on rye, turkey on white, turkey on wheat, turkey on rye, and so forth. And you can see them all there. And what I could do is I could just count all those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different choices there, so it tells me I've got 12. Or what I can do is I can make a little shortcut, and instead of doing that, I just take my number of meats, which is 4, and multiply that by my number of bread, which is 3, and 4 times 3 is 12. So we could use this tree diagram, but imagine if you had like lots of different choices. These branches just get crazy. You end up with a lot. If I've got 96 different choices, I'd have 96 different branches at the end. I really don't want to draw that. So we came up with this fundamental counting principle that just shortens it down, so we just multiply. Moving on here. Looking at another one. How many possible outfit combinations can you form if you have 4 shirts and 3 pairs of jeans? Well, again, same type of problem. 4 shirts, that'd be my event 1. 3 pairs of jeans, that'd be my event 2. How many different ones can I put together? I just multiply 4 times 3 and get 12 as my answer. Not too bad so far. Well, what if I've got more than 2 events? Well, we say 3 events can occur M, N, and this time P ways. Again, M, N, and P are just numbers. Then the number of ways all 3 can occur is M times N times P. So if you have 3 or more events, you just multiply the number of ways each event can occur. Looking here, I've got that sandwich again, but this time I'm going to have a choices of 3 cheeses for my sandwiches. Well, what am I going to do there? I'm just going to take 4 times 3 times 3. It's going to add a cheese each time. And 4 times 3 times 3 is 36. So now I went from 12 choices of sandwiches to 36 choices by just adding those 3 choices of cheeses. Alright, moving on. Here are 2 different problems. And this would be the time where you would just pause, see if you could solve these 2 problems on your own. And then we come back together and do them together. So I'd give you some time here. And when you're done, you'd come back and we look at a restaurant at Shadow Lake. You have the choice of 8 different entrees, 2 different salads, 12 different drinks, and 6 different choices. How many different dinners, if I take one of each of those for my dinner, can I choose? Well, what I like to do is I actually like to go in and I'll circle those. I'll circle those actual numbers. Okay, what numbers do I have? Okay, here's the 4 numbers I've got. And what do I do with them? I multiply them. 8 times 2 times 12 times 6. And multiply those together, we get 1,152, which tells me I've actually got 1,000 different, well, 1,152 exactly, different dinners to choose from at that one restaurant. Crazy if you think about it. In the other example, it says, how many different ways can a car be ordered if there are 5 possible colors, if it is automatic or standard, if it is powered by gas, electric, or hybrid, and if it comes with or without GPS. Well, this is what they'll do sometimes. They'll give us that number 5, but on the other one it says, is it automatic or standard? Well, that's actually 2 different possible choices, so I'll just write in a 2 there to let me know, okay, that one's got 2. Next it says if it is powered by gas, electric, or hybrid. That's completely different from automatic or standard. That's another choice I have for my car. So there I've got 1, 2, 3, so I've got a 3. And if it comes with or without GPS, well, with is a choice, or without, that's 2. So my numbers here are 5, 2 choices there, 3 choices, and 2 choices. And I go together and multiply those and get 60. Second one, a little more tricky. If you didn't get that one quite, hopefully now you understand what they might try to do to trick you a little bit. Okay, so there's just some basic fundamental counting principle rules, problems. Moving on here, what happens if there's repetition? Well, what's that mean? Well, if we look at Ohio, the state of Ohio, their license plates have 3 numbers followed by 3 letters. How many different license plates are possible if digits and letters can be repeated? So what I'm doing is I've got a license plate, it's got 3 numbers and then 3 letters. So a possible one would be like 1, 2, 3, ABC. And I can use any of the numbers or any of the letters. Well, I have 10 choices for digits. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So there's 10 choices for digits and 26 choices for letters, A through Z. How I solve that is, what do I have? Well, I've got 3 spots here for numbers and then 3 spots for letters. Okay? And those are each of my choices for my license plate. Well, the first one's got to be a number, so I've got 10 choices for that first number, 0 through 9. Okay, and it can repeat the second time, so I can have 1 and then 1 again. So on the second one, I'm going to also have 10 choices. On my third one, I can get 1, 1, 1, and it can repeat again, so I'll have 10 more choices. Okay, those are just each letters. Now, on the second 3, it's a number, or it's a letter, sorry. And for the first one, I could have A through Z, which is 26. Second one, if I have an A, I can have an A again, which is 26 again. Third one could also be 26, so they could all be 26 of the different letters there. Well, all I do now is fundamental counting principle. I multiply my choices. Multiply all 3 of these together, you get, oh boy, 17,576,000 different plates. So there's that many different plates you could possibly have in Ohio. Gets kind of crazy there. That's why they have so many cars, I'm sure. All right. Well, that was with repetition. Now let's look without repetition. So now I can't have like 1, 1, 1, A. They can't repeat. Well, now if I think about it, there's still 10 choices for that first digit, 0 through 9. But if I pick 0 for the first one, I can't pick it for the second one, so now there's only 9 choices. If I pick 1 for the second one, I can't pick it again for the third one, so now there's only 8. It just goes down 1 each time. Same thing with letters. If I pick A for the first one, I can't pick it for the second one. So I go down from 26 choices. For the second one, I only have 25. And again, how I do this is I just make spots. So what am I looking for? I'm looking for 3 numbers followed by 3 letters. Well, my numbers, how many choices do I have for that first one? I've got 10. How many choices do I have for the second one? Only 9 now, because I picked one and it can't be the same. It cannot be repeated. How about that third one? I've got 8. Now I get to letters. I've got 26. Then I've got 25. Then I've got 24. So if they cannot be repeated, these are my choices for each one. Multiply those together, and you get 11,232,000 choices for license plates. So if letters are not repeated, I lost almost 6 million license plates. There's that many less. All right, looking pretty good there. Here's a question, just a couple more examples here. How many different 7-digit phone numbers are possible if the first digit cannot be a 0 or a 1? Well, I would try to do 7 spots, 7-digit phone number, so I make out 7 spots. And each of those, I've got 10 choices, except for the first one, because it can't be a 0 or 1, so there's only 8 choices. So I make my 7 spots, put in my number of choices, 8 times 10 times 10 times 10 times 10, that's 8 million. So there's 8 million different phone numbers there. Last example here, what about a test? A multiple choice test has 10 questions with 4 answers each. How many ways can you complete the test? So how many different answers could I put down? Well, how many are there? There's 10. So I've got 10 spots. Each of them has 4 different answers I could put. So that's 4 times 4 times 4 times 4 times 4 times 4, 10 times, or 4 to the 10th, which is 1,048,576. All right, there we go. Repetition, non-repetition. Here are 2 questions. Go ahead, see if you can solve these on your own here. Give you a little bit of time. Pause it and then come back. Hopefully you've came back now. So looking at our license plates, we're given with 2 digits followed by 4 letters. So 2 digits, 4 letters. I've got 2 spots there. First one says they can repeat. So if they can repeat 2 digits, I've got 10 choices for the first one, 10 choices for the second one. Letters, I've got 26. They can repeat, so I've got 26 for all of them. And then what I do is I would multiply those numbers together. For the second one, they cannot repeat, so I've got 10 choices for the first number, but if I pick one, I can't have it again, so I've only got 9 choices for the next one. 4 letters, I've got 26 for the first one, but if I pick A, I can't do it again, so there's only 25. If I pick Z, I can't do it again, so there's only 24 and only 23. Multiply those out, you should get your answers right there. Use your calculator, multiply those out to get an answer. All right. With that, that's the end of episode 1. Next time we come back, we're going to look at permutations. Again, go ahead, try to rewind, pause, fast forward, rewatch things as much as you need to do. Good night, Titans.